We'll be doing our homemade ice cream lab. We will be using Ziploc bags, an empty container, salt, ice, milk, sugar, and other additional ingredients to make an ice cream.
Our first step was to pour the substance into a Ziploc bag. One of our partners created a tasty banana and milk mixture so that we could create the ice cream with it. Notice how the cream is liquid because it is at room temperature. It is in the stage of fluidity, which is the ability to flow. A liquid takes the shape of its container, in this case, the plastic bag, but its volume stays fixed.
Salt helps to bring the ice to a colder temperature. Ice cream freezes because the salt and ice mix to form a substance with a lower freezing point than just ice. Since the ice keeps melting but the water no longer freezes, the temperature goes down. Salt makes the substance freeze at a lower temperature than 0 degrees.
Because salt mixes with ice to form a lower freezing point, if both substances are left on skin, it creates a cold blister. Now back to our experiment. The ice is currently at a solid state because its particles have strong attractive forces acting between them. These forces limit the motion of the particles to vibrations around fixed locations in the solid, creating more order in the solid either than a liquid or gas whose particles are freely moving. The container kept the ice and salt packed together tightly and prevented the water from dripping after the ice began to melt. So then, we put the liquid cream into the container and close the lid. As you can see, some people are really excited.
You guys are making ice cream?
As salt is applied to ice, the ice crystal structure is broken due to the depressed freezing point of the resulting brine solution. As the salt continues to dissolve, more ice melts to accommodate this concentrated salt solution with its very low melting point. At the same time, both the heat of solution of the dissolving salt and the latent heat of fusion of the melting ice are absorbed from the ice itself, thereby lowering the temperature of the salt and ice mixture. Freezing point depression of a solution is a colligative property associated with the number of dissolved molecules. It means it depends on the ratio of the molecules. The lower the molecular weight, the greater the ability of a molecule to depress the freezing point.
Sodium and the chlorine in the salt split apart into charged ions, and these ions attract water molecules to form weak chemical bonds.
In order to make our ice cream quicker, we needed to shake the container. Luckily, we got help from a very enthusiastic friend.
Shake that for me, shake that for me. Come on, girl, shake that for me, shake that for me. Oh, girl, shake that.
heat from our hands and from the milk mixture which result in the ice melting. When ice melts, the surface gets wet. Some water molecules are leaving the ice and moving to the watery surface of the ice. At equilibrium, the heat lost by the water as it freezes is equal to the heat gained by the ice as it melts.
By shaking the plastic container, the salt and ice mix together more efficiently, allowing for the cream substance to freeze at a faster pace. The viscosity of the cream substance decreased because it was receiving cold temperature from its surrounding. This means the measure of the resistance of the liquid to flow decreased, making the substance thicker. While the cream started to get cold, the ice started melting because the heat from the cream was being transferred to the ice, so we had to constantly dump the water out. Our homemade ice cream was now ready to eat. Thank you so much for watching.